Hello everyone, I'm Avinash Kumar Singh, PhD research scholar and Special Head for Nanoscience, Jawaharlal University, New Delhi. Today I will present degradation of methyl parathion using manganese oxide nanoparticles through photocatalysis reactions. So here the content of my research work: introduction, manganese oxide nanomaterial synthesis, manganese oxide nanomaterial characterization studies, photocatalytic degradation studies, and finally I will conclude my research work. So the methyl parathion is a group of organophosphate compound that has been used as a pesticide for agricultural purpose. It is also known to be dimethyl para-nitrophenyl phosphorothioate. It is an ester of phosphoric acid and exists in two forms, thione and ozone. However, parathion is a group of highly toxic compound which is extensively used in agriculture crops, especially for cotton, soybean, corn, wheat, alfalfa, vegetables, fruit trees, and domestic activities. There are many adverse effects of these parathions. That's why parathions is classified in class 1 insecticide category. So having this parathion having toxic in nature, so that's why US Environmental Protection Agency has restricted this MP long back. It is also harmful to human health, and its absorption, inhalation, and contact with material contamination affect affect the human health. Moreover, exposure of MP also responsible for cardiovascular effect and mutagenic effects. This is the molecular structure of methyl parathion. So here the manganese oxide nanoparticles has been utilized as a catalysis to degrade the methyl parathion, and this manganese oxide nanoparticles is synthesized through co-precipitation route. So in this process, manganese acetate and sodium hydroxide has been utilized as a precursor. So in this process relates three process. This process relates a mixing of these precursor, filtration, and calcination, and finally obtain these nanoparticles. So this is the chemical reaction behind the synthesis of these nanoparticles. So this nanoparticles is characterized by uh, characterized by UV visible spectroscopy and scanning photon microscopy. So so this so in this UV visible spectra, the absorption is being obtained around 400 nanometer, and this inset plot is showing the top plot, which is used to calculate the band gap energy, and this plot is showing the scanning electron microscopy. So in this plot, the particle size of manganese oxide was found 500 pound spherical, aggregated spherical in spherical. So this is the photo degradation result for MP. So in this result, there are three systems has been. So So the photocatalytic degradation studies were performed between 0 to 120 minutes for the three systems, and it is recorded in dark, visible, and UV region. And this is the UV visible plot, and here you can see the intensity of the methyl parathion is decreasing with the time, and instead plot is showing the kinetic study of degradation under UV light. So this is the photocatalytic detection mechanism. So in this case, this manganese oxide nanoparticles is used as a catalyst, or you can say the semiconducting materials. And this is the methyl parathion, which is aggregated on the surface of manganese oxide nanoparticles. So firstly, this methyl parathion is aggregated on the manganese oxide nanoparticles. So here, the light irradiated on the surface of semiconducting materials are catalysis, and the electron present in the valence band get agitated and moves towards the conduction band. And in this case, the holes left in the valence band, and these holes react with water molecules and produce hydroxyl ions, hydroxyl radicals, and these hydroxyl radicals react with methyl parathion molecules and convert it into carbon dioxide and water molecules. So in this case, this is the process to degrade any organic molecules like uh, dye, pesticide, and mycotoxins. So this is the overall study of degradation of methyl parathion, which is done by using this manganese oxide nanoparticles. So this is the overall conclusion of my research work. The optical property and morphology of manganese oxide nanoparticles was characterized by UV visible and scanning electron microscopy, and the degradation of MP was carried out using photocatalytic process using manganese oxide nanomaterial in UV visible region. The photocatalysis study was with performed in dark, under visible light, under UV light, and the corresponding percentage was recorded: 40%, 58%, and 72%. The pseudo first order rate constant was calculated 0.02 for UV light. This is my supervisor, Dr. Prathama Solanki, and they are my lab mates. And I will and thank you all.